Hello! Welcome to today's lesson on magnetic flux density. We will begin today's lesson by reviewing the concept that magnetic field lines indicate the direction and strength of a magnetic field. We will learn that the closer these magnetic field lines are, the denser the magnetic flux, indicating a stronger magnetic field. We'll also introduce terminology to help us define the idea of magnetic flux density. Finally, we'll explore the calculations and units associated with magnetic flux density. In our previous lessons, we discussed the concept of magnetic field lines. These lines help us visualize the invisible force that surrounds a magnet. They emerge from the North Pole and curve around to enter the South Pole of a magnet. We use these lines to represent the magnetic field, which indicates both the direction and the strength of the magnetic field. These magnetic field lines can also be referred to as lines of magnetic flux. Just to recap, magnetic flux lines are continuous loops that show the path a north-seeking pole of a compass would follow if it was placed in the magnetic field. When we place a conductor in this magnetic field, it interacts with the magnetic flux lines, which is foundational to understanding electromagnetic phenomena. Now let's introduce the concept of magnetic flux density. Magnetic flux density, denoted by the symbol B, measures how many magnetic flux lines pass through a unit area. Simply put, it tells us how compact or spread out the magnetic field lines are, which in turn tells us the strength of the magnetic field at a particular point. When the magnetic flux lines are closer together, the magnetic field is stronger, and thus the magnetic flux density is higher. Conversely, when the lines are further apart, the magnetic flux density is lower, indicating a weaker magnetic field. To quantify magnetic flux density, we need to measure how many magnetic flux lines pass through a given area. This brings us to the unit of magnetic flux density, which is the Tesla, T. 1 Tesla is defined as 1 Weber per square metre, where the Weber, WB, is the unit of magnetic flux. To help visualize, imagine placing a small square in the magnetic field. Count how many magnetic flux lines pass through this square. In this case, we have 3 lines. The number of lines that pass through each unit of area represents the magnetic flux density. For example, if 5 flux lines pass through 1 square metre, the magnetic flux density at that point would be 5 Teslas. In today's lesson, we delved into the concept of magnetic flux density, building on our knowledge of magnetic field lines. We reviewed that magnetic field lines represent the direction and strength of a magnetic field, and when these lines are closer together, the field is stronger. We introduced magnetic flux density, symbolized as B, which measures the concentration of magnetic flux lines per unit area and indicates the strength of the magnetic field at a specific point. We learned that the unit of magnetic flux density is the Tesla, T, which is equivalent to 1 Weber per square metre. Understanding magnetic flux density not only helps in analyzing magnetic fields, but also in designing and optimizing devices like electric motors and transformers. Watch the rest of the GCSE physics course at Sophos Education